सत्र में हम लोग तीन प्रस्तुतियां दे रहे हैं। पहली हमारी सेस्मिक रेजिलेंस एंड कंस्ट्रक्शन ऑटोमेशन पर है। इसके लिए मैं आमंत्रित कर रहा हूं डॉक्टर अजय चौरसिया को अपनी प्रस्तुति के लिए। डॉक्टर अजय चौरसिया।
धन्यवाद डॉक्टर चौहान। गुड आफ्टरनून, dignitaries on the dais. It is my pleasant duty to present CSIR-CBRI's contribution on seismic resilience and construction automation. So, in brief, as mentioned by our guest, Dr. Sen also, that when we talk about the India, we know that the Indian plate is subducting into the Eurasian plate, and as a result, the entire Uttarakhand is highly vulnerable. And now today's my presentations will be focusing towards CBRI's contributions in strengthening and building back these resilient Uttarakhand. So we know Uttarakhand lies in seismic zone 4 and 5. In contrast, when you see the construction technologies across the country or across the globe, so there are 5 levels of construction technologies. Most of the construction happening in Uttarakhand is in material centric, level 0. Now we want to bring back it is to ultra high-end technologies, that is level 3, level 4. Yes, that is the 3D concrete printed buildings, which is very, very good propositions for the rural sectors as well as volumetric constructions. So in brief, the CBRI's journey for masonry buildings in last 2.5 decades has been shown here, which is very, very pertinent in view of the 85% of existing building stocks in our country is masonry one. And when we are talking about the building back seismic resilient buildings in Uttarakhand, this is a very pertinent topic because most unreinforced masonry known for their vulnerability. So that's why we have come out with the confined masonry, which is cost effective, makes use of locally available construction materials, skills, and thermal comfort. So this has been explored through extensive experimental investigations, and as a result we formulated the Indian standards. Now we are concerned about existing buildings which can be retrofitted by various locally available construction materials and skills, which will be a cost effective technology. So this is another step to make the existing building stocks seismic resilient, and that is a very, very important takeaway for state of Uttarakhand. In fact, prefabricated buildings are also equally important when you talk about the speed, and for that purpose, CBRI offers a basket of precast construction technologies in the form of a components, that is a RC plank joist, arch loop, and at the same time, mechanization has also been taken place at a greater depth. And when you talk about the prefabricated buildings, they are known for its seismic vulnerability, and for that purpose, full-scale experimental investigations have also been taken up at CBRI, and how to go it forward, that has been addressed. When you are looking for the emerging construction technologies, how they can be made robust in all perspective, that has been well demonstrated in our construction technology demonstration park. I request you all to visit our demo park at Roorkee. Beam column joints is another challenge. To overcome the challenge in terms of congestion of reinforcement, which makes poor and workmanship, which makes poor performance of beam column joints, we offer headed bars. Similarly, from thermal point of view and adding speed to the constructions, lightweight cellular blocks are also available, and which have been tested at CBRI. So to further enforce the automation, plastering machines, mini climbing cranes are the well addressed proposals even for the medium scale contractors. To add speed to the constructions, we offer the investigations on 3D concrete buildings and prefabricated buildings of volumetric constructions, and the technology is now being implemented in Lighthouse project at Ranchi. So another important aspect is how to strengthen our existing experimental test facility. For that purpose, CBRI has already developed a full-scale test where we can test up to 4-story building when we are talking about the rural sectors, yes, CBRI has done extensive work and offers the 130 designs in 13 different states and which has been widely accepted across the country. The standardization and modularization is also one of the important aspects which has been very well tabulated and composed in 2 documents for rural sectors, Pahelis, and in contrast for the urban and rural both. It is a construction building compendium of building technologies jointly released by CBRI and BMTPC. At the same time, CBRI has developed prefabricated makeshift hospitals which has been widely implemented across the country, and now the same technology is likely to be implemented in the affected region or rehabilitations of Joshimath disaster. Equally important to protect the heritage, particularly post-disasters, contribution of CBRI in redevelopment of Kedarnath, Badrinath and other seismic vulnerability assessment and strengthening the existing building stocks, particularly lifeline buildings, is very much required as per CSIR 2015. And in short, I will say that CBRI is always ready to handhold with government of Uttarakhand to make the state seismic resilient. Thank you everyone, ladies and gentlemen, for your kind attention and patience in hearing. May I now request Dr. Harpal Singh for the next presentation on disaster fire hazard and disasters, particularly from forest fire is concerned. Thank you.
Good afternoon. Other than this landslide and earthquake, fire is also a part of disaster, which are unfortunately occurs time to time. CSIR-CBRI has a full-fledged fire engineering department at CSIR-CBRI into the service of the nation. And the fire department is doing research in all the areas of fire engineering, either it is active fire protection or passive fire protection, either it is the fire audit of the existing building in the countries, or unfortunately when fire occurs somewhere, then CBRI also does the post-fire investigation, and we are also dealing with the this forest fire, which is generally occur during the summer time. So CBRI has done a lot of R&D regarding the this passive fire protection of all kind of buildings. So CBRI has developed various technologies, like you see the first one is the fire retardant and water repellent canvas, which is generally used for the fire protection and water problems of the temporary structures. Another one is the rigid polyurethane foam, which is generally used as a insulation materials inside the buildings. But this material is highly flammable and on burning generate lot of toxic gases. So this material has been made fire retardant at the compounding stage, and this technology is ready for commercial exploitation. Another one is the this sandwich panels, which is again based on the rigid polyurethane foam, and these can be used as a lining material as well as for the partitions. Another one is the fire blocking layer, Virtually it is a thick cotton tanning which is treated with the fire retardant composition, and this material is used as a intermediate lining material. Means suppose if a material is highly flammable, so this material can be used as a cover over that material so that the material can be safe during the fire incident. Another one is the fire resistant sealant, which is generally used for the sealing of the cables, and during the fire exposure this fire resistant sealant has a chemical action and intumescizes and fills all the voids and gaps and prevent the penetration of hot gases and smoke to the other side of the compartment. And these are few more technologies like fire retardant water-based transparent coating, which is generally used for wood and wood substitutes. Then fire resistant doors for 1 hour fire resistance rating and 2 hour fire resistance rating. Then fire retardant intumescent cable coating. When this coating is applied on the cables and on exposure to ignition source, the coating is intumescizes, and this intumescence char acts as a insulating blanket between the ignition source and the substrate. And then fire safe micro data cabinet, fire retardant cotton and synthetic fabrics, and also the spalling mitigation technology for high strength concrete. The CBRI also has the full scale fire test facilities for structural elements, structural components, and all kinds of building materials. If you see, the CBRI has a full size fire test facility in the form of wall furnace, floor furnace, and when you investigate the fire behavior of the materials, then we have a full-fledged laboratory for reaction to fire characteristics, and we also have a full-size room to test the all kinds of lining materials. Means in case of fire incident, how these lining materials behave inside a full room size. This is the picture of this wall furnace, and this is the photograph of the floor furnace. And when we investigate the different kinds of building materials, so this is the photograph of the surface spread of flame. Means when a material is exposed to ignition source, how the flame is travel on the surface of the material. And then this is the fire propagation index, means during the fire how much quantity of heat that material is generating during the fire incident. Another one is the ignitability, whether the material is easily ignitable or not. Another one, during the fire incident, how much quantity of smoke that material is generating. Again, and the smoke and combustion products during the fire incident. So, what are the toxic combustion products? We have a full-fledged facility at CBRI. Then this is the advanced level of facilities. By using this dual cone calorimeter, we can easily investigate the effective heat of combustion and heat release days of the material during the fire incident. And this is the limiting oxygen index characteristics, means how a material is behave when the atmosphere is highly enriched in oxygen. And then we have a full-fledged full room facility for the investigation of the different kinds of material. And these materials can be tested at CBRI, almost following all the standards like Indian standard, ES, ISO, NES, DSEL, UL standards, and ASTM standards also. And you see, these are the full-size samples which can be tested at CBRI. Either it is wall, or you can say beam, column, partition, ceiling, duct, door, dampers, cable coating, tunnel segment, cable fire stove. Every kind of samples can be tested at CBRI in full scale. And these are some of the photographs of the samples tested at CBRI. This is lift door, and this is the photograph of metal door. This is fire curtain. One thing I would like to mention here that these fire curtains are installed at Parliament building, old Parliament building, and these fire curtains are installed by a outside agency and imported from US. And they claiming that these fire curtains having a fire resistance rating of 4 hours. So after the intervention of the Supreme Court, this material is tested in CBRI, and I would like to tell you that this sample is failed after 30 minutes. So rather than he is claiming 4 hour fire resistance rating, it was failed just after 30 minutes. And this is the steel I-beam which is coated with the indomescent fire resistant coating. This is cable fire store by using the fire resistant sealing. And this is the vertical duct. This is horizontal duct. And this is the tunnel segment. And this is the partition. And that's all. Thank you.
जैसा कि आप सभी जानते हैं कि डॉक्टर कानूनगो है ऑलरेडी लैब फॉर जोशीमठ, तो एक उनका जो प्रेजेंटेशन है वो मैं आपको यहाँ पर थोड़ा सा शेयर कर दे रहा हूँ. दिस इज अबाउट द प्रोग्राम इन जियो हजार्ड्स, व्हाट वी आर डूइंग इट. These are our areas of specialized, our vision, mission, and all that. Recently, the demolition of Twin Tower was a topic, or a hot cake topic before Joshivat. So in that, CBRI has played a key role in designing how the blast scheme will be there, how the blast will take place, and how we can protect the buildings which are surrounding. So you can see these are the buildings and how we have put some tires. You can see there in the picture, and how we are protecting the other structures which are nearby. These were the two towers, and you can see that we have in the black is the primary blast codes, then secondary blast codes, and the whites were there will be no blasting on that place. Then we have designed how the blasting will take place in total 9 seconds, and these are the demolition sequence, and how we have protected other existing structures. That was also very concerned because people were very much afraid that when these demolition will take place, then what will be for the other buildings. So in that we have designed you can say a wall, steel wall, and the tires so that no impact should go to the other buildings. And these are the you can say how the blasting points were decided and how they were done. It was meticulously done by our team, and you can see we covered the whole area with these big curtains so that the dust problem should be not there. Then we put the steel containers nearby, and in between the wall and this, the tires will be there, so there will be no shock should go to the other buildings. These type of tires were filled, and these were the wall created to avoid the shock, and these are again the things we did, and then the blasting took place. These are the boxes, and after the blasting, this type of demolition there. Then we come to our geotechnical engineering and geohazard group. We are doing in the soil mechanics, rock mechanics, and ground improvement and tunnel engineering. Then we are also working on the difficult ground conditions, difficult ground soils, how to make them work for construction. Then difficult terrains and hilly we are doing for the last, say, 30-40 years. And nowadays we are also working in the underground space area. We are capable of doing the geological, geophysical and geotechnical investigations in each and every type of climate, physiographic conditions. Then we are mainly working in the landslides area and on all the aspects of landslides. So we are doing the hazard assessment, vulnerability assessment and risk assessment and giving the solutions for different landslide problems. Then we have done some, you can say, the risk mapping, in particularly near Joshimath, before Joshimath, and try to map and identify the buildings which are in which risk. So this is about the risk assessment. Then in Tangni landslides, we have also done the runout modeling and try to know what is the hazard in the valley. And these are some studies of that. We try to do and we have created a facility, experimental setup for damage flow runout at our CBRI. And we are doing early warning system, and one system is installed in the Tangni and other with the IIT Roorkee. We are trying to put the sensors, different sensors and monitoring and doing landslide warning. So then we are doing some in the Nagaland Legislative Assembly Complex, there is a problem of landslides. There we have provided the solution, how we can encounter it. Then these are some we did the numerical modeling and then give the remedial measures for that. There are 5 meter anchors, 10 meter anchors, depends on the conditions of the slope. We did. Then we also provide the ring net and 3-dimension reinforced. This is the work going on there. Then in the Tungnath temple, again there was a problem, and we provided how the slope failure is taking place. On the basis of that, we provided so many solutions, how the geotextile filters should be, the Debian retaining wall, then geomembrane, anchor, all type of solutions we have suggested. And this is again on the Manipur highway corridor stabilization, and this work is also going on. We have given the measures and the suggestions, and they are doing implementing them there. Then Gadora landslide subsidence zone, we have also you can see in the distresses in the buildings as well as the landslide problem. Then we did some ERT surveys also and tried to get the real picture of the subsurface, and then we suggested a solutions of soil nailing, micropiles, even the gravity retaining wall. These are type of solutions we have suggested there. And again, the Mizoram highway corridor stabilization, this work is also going on, and implementation is now going on this area. Then these are the Japan walls designed by us for this highway. So these are some features which we are doing. Just a glimpse, because this was the presentation of Kavingo. If he will be there, then maybe a more detailed discussions could be there. So this was from my side. Thank you very much. Now,
you can write some questions.
Yes, yes. Now I request Harpalji and Ajay to come here, and if there are any questions, any queries, we can.
So, you can give the mic, please.
Starting to Chauhan ji, first of all, I congratulate all three speakers to showcase what CBRI has been doing on different aspects. And I am having certain observations and pertinent thing to be added if not done. One is that when you are telling landslide early warning, what are the triggering factors you are considering into the modeling? Only the rainfall, or tectonic movement, or anthropogenic impacts, or all three?
We are considering rain is the time, and some tectonic movement, as well as we are also considering about the inclinometers as well as pressure gauge. All those parameters are also considered in the modeling.
That will give, that you will be able to monitor.
Yeah.
But how you will decide the threshold for prediction or forewarning of the landslides? This is very critical part.
Yes, definitely. In that, sir, we are taking a data for 1 or 2 seasons and seeing the how movement is going on, and we are also taking the NCT and rainfall data also, and trying to, till now we have not decided the threshold, but because we are collecting a data, then only we can be able to give the solution. So still that triggering threshold part is not.
Very nice. This is need of the hour, and it will be useful to our Yoshimot also. Another important thing that last year also we had in 2022 February the Rishiganga flash flood, and still in the rivers there are a lot of debris flow, and particularly the hydroelectric power project stakeholders are in very much dire need of this type of warning system, whether it is landslides or maybe they are. So in that context, I'd like to know one thing, that is anybody doing the debris flow simulation or mass movement modeling at?
Yeah, debris flow modeling. Recently, one PhD was done by my student Dr. Rajesh Das, and he was doing all the debris modeling studies, as well as these landslide dams. So he is, after his PhD, now he is concentrating on other how the dams where how much volume can go. This all studies of debris modeling is going on very well. He has completed his PhD and is still continuing that sort of work for particularly Uttarakhand.
Very nice. And thank you, sir. Now I maybe have one question to you. That always we are in dilemma, and two schools of thoughts and beliefs that in the seismic gap. Generally, some people say gap, some people say still activities are going on, so we should not call it gap. Anyway, that you are also having some sort of GPS studies, or only seismological broadband seismometer studies, having some GPS also. So there, what is your opinion about many people are telling this gap, we should not call it gap only, in this region, in the Uttarakhand region, particularly Kumail Garhwal region, there may be a major earthquake of 7 magnitude, or maybe somebody is telling 8 magnitude, that may be a great earthquake. So what is your belief, whether it is reaching to the threshold, or before reaching to the threshold it is crept away or diffused, so that we will not envisage any major or great earthquake? What is your opinion? Have you done similar studies into that region?
Ajay, you can take that.
Yeah.
Thank you, sir. Very pertinent question you have raised in this August gathering. First, I will give answer in a three folds. First is hazard. In the hazard, as you rightly said, your Indian plate is subducting into Eurasian plate, and we know 47 mm per year. Our Himalayas are rising, energy is building up, and it may release either in a medium or large events also. So for that purpose, when you talk about CBRI, we are not, because there are other institutions which are constantly monitoring this activity, including IIT, Roorkee and other NGRI, then Ministry of Earth Science, etc. So we have not put in our effort in the instrumentation of, whereas whenever you talk about hazard vulnerability is very, very important, particularly for the existing building stocks. And for that purpose, extensive work has been done in CBRI. First of all, to mitigate how beautifully we can make existing building stocks seismic resilient. Thereafter, if whatever the new construction is happening, how to make it more cost effective, at the same time seismic resilient. And third, as per CNEDAC 2015 framework, how to make the existing infrastructural facilities like lifeline buildings, schools, hospitals, and important structures more seismic resilient.
Yeah, I got it. Your direction in that is little different what I am asking, and your mandate is also in that direction what you have been doing. But some thoughts can be given in the now onward that many years we have not been able to predict earthquake, but all of us know in the convergence zone, whenever there are strain accumulation, deformation of the rocks taking place, there may be changes into the, not maybe, it is happening, changes into the physical properties, maybe BBBs, there have been change resistivity, even gravity, and there will be some sort of changes into the groundwater level, radon gas emission, geotechnical properties. So you can not predict earthquake, but at least we have observed that before the main event takes place, there have been some sort of anomalous behavior of the changes into the physical properties, chemical properties, geotechnical properties. So if you constantly monitor, because monitoring is also one of the mandate of CBRI with regard to the earthquake disaster or mitigation or some sort of seismicity assessment. In that context, I think you can place some of these important sensors, geophysical sensors, if you have a group, just suggestion. Then you will be able to make what exactly happening into the spatio-temporal. If you have number of stations, spatially you will be able to know. If you have one station temporally, you will be able to know. From there, at least the precursory events will give you an idea that something unusual going to happen. Still, you will not be able to tell when, but you will be able to say that we are observing, and maybe after weeks or days or maybe months or years, based on certain observations. So this you can plan if possible. I know it needs different sets of people, different sets of expertise. You may or may not have, but you can think.
Sir, that is well taken, and definitely we'll look into this aspect. And as far as expertise of CBRI is concerned, I'm very happy that all kinds of expertise in multidisciplinary expertise we have, and definitely we'll look forward to address this issue also in our ongoing R&D.
In continuation to this, as I mentioned about the 3-4 months back also, that what are the strengths of Wadia Institute, where CBRI and Wadia can join hands together to address this particular problem. So I think this will be a great win-win situation where two institutions are working together for the state of Uttarakhand. I think you agreed during that period also that yes, we'll sign an MOU with CBRI on these particular aspects. Thank you. Thank you.
Another very important.
Sir, one thing I wanted to add, as far as you have talked about the prediction of the earthquakes. Clearly, that is far away from us even. But alert systems are worldwide, and IIT Roorkee has started this work. This work of computing the alert time and all that, the first pilot study was done by the CBRI. I was involved, part of the team which did these studies. But as in Wadia, because I am also geophysicist, but in Wadia, you are all are scientists of all disciplines. So maybe, and you are having the, even stations are also there in the Uttarakhand Himalaya. So, as Dr. Ashok Kumar has said, rightly said, then we can work together in some problems, and so that holistic solutions with respect to the earthquake we can give.
Yeah, I think this is a good suggestion. We will be working together. But my concern at this moment is not the prediction of the earthquake. My concern is to know what exactly happening to look into the precursory events.
Precursory.
And will not be able to say again, even
Yes,
if something
definitely.
unusual phenomena takes place
Yeah.
on the physical properties, chemical properties, geotechnical properties, we will not be able to say that where exactly something. But at least some alert will be given that we are observing some unusual phenomena. In coming years or coming months or coming weeks or coming days, something is going to happen. This is one question. Another thing, Director Sam is here or
No.
he is busy. This is very important, and I think he has done a lot of modeling, and that can be taken up. We are having some sort of webinar with the Russian scientist at Wadia, and then one of the Russian scientists he showed through lab studies as well as from field studies, which is not possible into our lab studies is possible, but field studies, whatever he has demonstrated, I will explain, is not possible into the Himalayan region because of its, if we do that type of experiment, something happen which will be dangerous. What he has shown through some modeling, that he created a very stressed regime, which is capable of producing an earthquake of magnitude 6. But what he showed, by injecting some electromagnetic wave into that field, into the high stress regime, he showed there are a lot of small magnitude earthquake taking place, and that energy which is capable of producing 6 magnitude earthquake is getting diffused in the form of small magnitude earthquake. Laboratory study, I think if you have some sort of modelers, some people are there, I think that can be done instead of going directly to the field, and it can be demonstrated. I am also here asking my scientist at Wadia. I also, 10 days, 15 days back, what NGRI, I was telling these things, whether it is possible to do some laboratory study, simulation study into the lab to understand whether really by sending electromagnetic wave, it is creating lot of small magnitude earthquake, equivalent to the 6 magnitude earthquake. So that if it's possible, it will give some sort of idea that particularly into the plain area or other area, that we'll be able to diffuse the energy. But in the hilly region, in the tectonically active region, Himalayan region, vulnerable region, we cannot take this type of risk. Whenever this laboratory study will give us strength to lab to field, we have to go. But in that field, I think we'll not be able to do that. So maybe this can be taken up, and that will be one of the important things.
Yeah, it's a very good proposition you made, and definitely we can work it together. And this proposition also looks very promising. We can begin with initially lab study in CBRI. Later on, it can be extended in the non-habitat area to validate our results. So I think we can take it forward by signing MOU between Wadia and CBRI.
I would like to add, yesterday we had this hackathon, and one of the participants, he gave this idea, and that was, team was adjudged as the second, runner-up in the hackathon.
Great.
So you can see the correlation between the idea and the students who are already working, thinking of, yes. So I think this idea can be taken up further by your team.
We can take up this particular MOU, and first objective is only this one.
Yes,
Yeah.
I was talking to scientists at NGRI also, NGRI and CBRI and Wadia. Wadia, we have very few geophysicists, a lot of geologists are there. So I think you should take it up. And this will,
That is the purpose of doing MOU, sir. So definitely we can add that to sir.
yes, our structure. Thank you.
Anyone else who would like to ask any questions? Yeah, that side.
Yes.
Good afternoon, sir. I am Pankaj Arya from Indian Institute of Petroleum. My question is to Dr. Harpal ji. As you mentioned in your presentation that a lot of research work is going on in the direction of fire engineering. So, in context to the state of Uttarakhand, as we know that because 70% of the area is covered with the forest, and forest fire is one of the major challenges that we face every year. So I would just like to know that what kind of research work is going on in CBRI in this direction to solve this problem.
Definitely, it is a very pertinent question. And for the last 2 years, we have started to do the R&D work on regarding the forest fire. And forest fire is usually occur during the summer time. So we have created some facility in the CBRI, and then we are trying to extinguish such kind of fire by using the different kinds of media. Either it is foaming extinguishers, or sometimes the mixture of chemicals. And even we are also trying at the laboratory level to make a fireball, and then these fireballs can be thrown up into the fire from a different various distances, and then as this chemical mixture ball drop down into the fire zone, the chemical explode into that area, and then a chemical reaction takes place, which ultimately prevent the spread of fire. So although right now we are in a very initial stage, okay, but in the coming time we definitely will take lead into the first fire.
Thank you, sir. We at CSIR-IIP, we are also working in this direction, sir. Recently, we have tried a few lab level experiments with dry ice, and we are taking help from NAL Bangalore because they have these small aerial vehicles which can drop these dry ice cubes or chemical balls into the fire. So I would like to request you that if possible that we can collaborate and work in this direction.
Definitely. I invite you to come at CBRI and see our facilities, and then definitely we can collaborate. And you know both CSIR and CSIR-CBRI and IIP both are the sister laboratories, so it's a great opportunity for both of us to come together and forward in the R&D direction.
Thank you, sir.
Sir, actually, you supposed to me ask me a question, but I am sorry, I am asking to a question, sir. Sir. Yes. Sir. Sir, actually, up to what level we can create a artificial earthquake? Up to what magnitude?
No, that's what we have to understand, because this mechanism, when he was presenting, we have not got. But he showed that 6 magnitude stress regime, and then he was showing that 1 magnitude, 0.5 magnitude or 1.5, very small magnitude earthquake have been generated, and that energy has been diffused like that. But now actual physics, actual control, that I have not understood. Maybe by doing modeling, by doing simulation in the lab, the person concerned will be understanding. So it is not very clear to me also. Sometimes according to me, that entire energy may be released. Then we are doing something and then creating hazard. So we have to understand all these things by doing experiment into laboratory, simulating into the laboratory. Otherwise, it cannot be made into the field. Lab to field, it can't be done unless we understand holistically, fully, comprehensive way into the lab. So that's what we have to understand.
No,
you can. I think it would be better that I request Professor Ashok Kumar to conclude.
Okay. Thank you, Dr. Ajay, for giving me this opportunity to conclude. At the outset, I would like to convey my regards and thanks to Dr. Sai for sparing his valuable time this morning and gracing this occasion as chief guest, and also thanks are due to Mr. Ashok Kumar, who was the guest of honor for today's morning session, and I am very happy to say that although the strength was not so good, but the way our three speakers have conveyed their outcomes of the projects and how these outcomes or outputs or the technologies, materials, or the know-how that CBRI has developed over the last 75 years that can be made useful for the state of Uttarakhand. Apart from whatever has been mentioned, I would like to add further that right from the day one when I joined CBRI in the year 1990, we had this earthquake of Uttarakhand, and then we also had earthquake of Chamoli during March 29, 1999. So in all these earthquakes and even landslides, CBRI has recommended several kinds of temporary, transit and permanent shelter designs, and these shelters were adopted by the then government of UP, and many such shelters were developed across these regions, Uttarakhand and Chamoli regions, and even today you will find these shelters quite useful. Similarly, the buildings which were built using the technologies of CBRI, like concrete blocks, when we surveyed these buildings in the area of Roorkee and Chamoli, these buildings were not having any damage. So you can see that the buildings which were non-engineered and the buildings which were engineered, they didn't have, particularly the one which I am talking about, concrete block, they didn't have any damage. So I think right from the early years, I can say when I joined CBRI in the year 1990 till today, CBRI has been playing a very, very important role in giving solutions to all kinds of problems of the region, and will continue to do so. And you can see the spirit of the scientists of CBRI. They were there in Joshimath yesterday, and today also they have gone. They have, I think, left for Joshimath to give immediate solutions to the problems of subsidence in the area of Joshimath. And I'm sure the young team which is here and this with young and old, this is a very good mix. I think the years to come will have more such occasions where we can invite many people from the administration side, because whatever knowledge that we have at the institute level, it must reach to the administration, so that they should know that yes, this is the knowledge which is available within the state. They should not run to outside Uttarakhand and request for expert opinions, right? So with these words, thank you very much for joining, and I think we can break. I can request Dr. Karade to say a few words or propose a vote of thanks. Thank you.
Thank you, Ashok ji, Dr. Ajay, Dr. Harpal ji, Dr. Pradeep Chauhan, today's chief guest, Dr. Kala Chand ji, and friends, all participants. It's my pleasant duty to propose a vote of thanks at the end of this program. So first of all, we would like to thank today's chief guest, Dr. Kala Chand Sai ji, for sparing his valuable time. हमने उन्हें पहले भी बुलाया था CBRI, और उन्होंने हमारे साथ आके और समय बिताया, और इससे उनका प्यार झलकता है CBRI के लिए. और जैसा सभी लोग कह रहे थे कि वाडिया और CBRI closely they can work, so we hope this association will continue. Thank you, sir. I am also thankful to today's guest of honor, Mr. Ashok Kumar, DGP, Uttarakhand, for coming here despite so many things happening in the state at present. He find out some time for us. Thanks to him. Then we would like to thank our director, who is the motivational force for this organizing team. And for Dr. Sai, we would like to tell that this is only 15 days was given to us, and our team, whole CBRI, has managed to do these 7 days various program of 20 events. So you can imagine.
Even during the crisis going
yes,
on.
Yes. Despite all this crisis and this period, it was really difficult. But anyway, we have managed, and we are thankful to our director for given all the liberty. And I would like to thank today's coordinators, Dr. Harpal Singh ji, Dr. Kanungo, Dr. Ajay Chaurasia, for arranging this program. Despite, again, you know, till yesterday night they were very busy. And again, Dr. Kanungo has already left. So thank you to all, and all our participants and colleagues from here, press and media. Thank you very much. Thanks a lot.
धन्यवाद डॉक्टर सुखदेव कराड़े जी। अब मैं आपको लंच से बुलाने से पहले सिर्फ ये कहना चाहूँगा कि हम CBRI वाले इस बात में यकीन रखते हैं, द शो मस्ट गो ऑन, और हमारे कर्तव्य अलग अलग जगह हो सकते हैं, लेकिन हमारा शो, हमारा प्रतिबद्धता जो हमने ली है उसे हम पूरा करते रहेंगे। इसी के साथ आज के कार्यक्रम का हम यहीं समाप्त कर रहे हैं और आप सभी को बाहर लंच के लिए आमंत्रित करते हैं। धन्यवाद।
Nice meeting again. Physical meeting. That was online meeting.